Assalamu alaikum students. Hope you all are doing good. Students, we are on the chapter number 11 of your physics books, that is effect of heat energy. Today we'll complete this chapter, inshallah. So I request you all to please be attentive during the lecture. So our today's objective will be review of the previous topics, liquid and glass thermometer, the ice and steam point, measuring temperature, and then the conclusion. So let's start. So students, let's have a quick review of what we have studied in the previous lectures or in the previous classes. So we have studied the thermal expansion and thermal contraction, which is thermal expansion is the tendency of a matter to change its shape, area, and volume in response to a change in temperature. And the controversial of this thermal contraction is the shrinking of substances as they cool. Changes in temperature change the physical property of substance. Then we've put the light on the thermal expansion of solids, liquids, and gases, how they take place in these basic three states of matter. Then we have discussed the effects of expansion and contraction in everyday life. We have discussed some of the useful effects of thermal expansion and contraction. And we have discussed some nuisance effects or some harmful effects of thermal expansion and contraction. Meanwhile, we have also seen the remedial measures in order to overcome on the nuisance or the harmful effect of thermal expansion and contraction. So as you can see here, then after that, we have discussed the applications of thermal expansion and contraction, its application in the hot air balloon, then in the electrical appliances, in the cart wheel, the process of riveting in order to fix or join two steel plates or girders, and in the process of fire alarm and indicators of car. So this was all about what we have studied in the previous topics or in the previous lectures. Let's begin with our today's lecture, that is liquid in glass thermometer. So, liquid and glass thermometers use the thermal expansion and contraction of liquid to measure temperature. Most liquid and glass thermometers are filled with either mercury or alcohol, or sometimes with glycerine as well. So, as you can see in the picture here, this is the liquid and glass thermometer. This is the liquid bulb in which mercury or any other type of liquid, example alcohol, glycerine, etc., are filled. This is basically the liquid thread, which indicates the temperature increase or either decrease. This is basically the narrow glass tube in which this liquid thread moves up and down. And these numbers which you can see in this diagram shows the linear scale or the main scale that gives the reading of temperatures. So whenever the temperature rises, the liquid expands, and whenever the temperature decreases, the liquid shrinks or contracts into this bulb. It's another type of liquid and glass thermometer, which is clinical thermometer, as it makes use of mercury, which is in liquid state at room temperature or atmospheric pressure. So, a thermometer, this clinical thermometer, works on the principle that liquids expands on heating, that is, thermal expansion and contraction, the same as we have discussed in the liquid and glass thermometer topic. As the temperature rises, mercury expands, causing it to move upward and depicts the temperature. This is basically the thermometer which we use in our daily life at our homes. So, this is basically the bulb, the glass bulb, which contains mercury inside it. Here we have a contraction chamber, or also known as constriction. The reading which you can see up here or down in here is known as basically the main scale. One is in degree centigrade and one is in degree Fahrenheit. And this is the expansion chamber. So, why this type of clinical thermometer have a constriction in it, and why not the other type of liquid and glass thermometer do not have this constriction? So the basic reason is, in order to prevent the backward flow of the liquid which is inside this capillary tube or this bulb, so that it will be convenient for the observer to find out the temperature of certain object, or for example of certain human. So whenever this thermometer is kept into the mouth of the affected person, so after a while, when this thermometer will be taken out from his mouth, or from the hand, for example if the person is a child, so if the temperature of the body is normal, that is 37 degrees Celsius, then you can see that the mercury will be up till 37 degrees Celsius. Or if the person is infected, or he or she may have a fever, then you can see this mercury moving upwards, indicating that the person is infected. So the basic reason why constriction has been added into such type of thermometer is that whenever the thermometer is out of for example, mouth of a person, so whenever the person wants to observe the temperature, so he can measure, or he can find out the reading easily, because the thermometer will be for example rest at that point, will not move backward because of this constriction. So as we have discussed now that the constriction has been added into the clinical thermometer while it is not present in the other liquid and glass or the laboratory thermometers, so and does not have these laboratory thermometers does not have a constriction, so that when the temperature of something drops, the reading on the thermometer drops. Of course you have to read it in a situ. So in laboratory we have to do different sorts of experiments. For example, when you are in your chemistry lab or in your physics lab and want to find out the boiling point or the melting point of something, or for example of any chemical, so you have to find that point um, at once. So this liquid, because of the absence of this constriction, will move quickly or gently upward or downward, indicating the temperature change. So in the laboratory thermometer, here is also the red arrow. One here in the picture, one is degree Celsius and the other is degree Fahrenheit. This red mark shows basically the normal body temperature. So, as we have discussed earlier, that it is because of the special feature constriction that the thermometer may be removed from the patient's body and carried to a well lighted place to read the temperature. This is basically they are basically talking about the clinical thermometer here. The scale is marked on a glass envelope in Celsius or degree Fahrenheit in which the capillary tube is kept. These thermometers are calibrated from 35 degrees Celsius to 40 degrees Celsius since the human body temperature falls in this range. So here they are basically talking about the construction of most of the types of thermometers that we use. So this was the basic reason or the difference between the laboratory thermometer and the clinical thermometer. Let's move on to our next topic, that is about the ice and the steam point. The ice point is also called a lower fixed point, and the steam point is also known as upper fixed point. As you can see here in the diagram as well, one thermometer is of degree Celsius and the other is giving reading in degree Fahrenheit. So 0 degree Celsius or 32 degree Fahrenheit here indicates the freezing point of water, or you can say that the point at which the water or the ice starts melting. And at 100 degree Celsius or 212 degree Fahrenheit, the water starts to boil, or you can say the water starts to convert into vapors or steam here. So this is considered as the steam point, and this 0 degree Celsius or 32 degree Fahrenheit is considered as the freezing point or the ice point or lower fixed point of the thermometer. So let's discuss the ice point in a bit detail. So, in 1742, a Swedish astronomer named Anders Celsius selected the fixed point as follows. The ice point is basically the temperature of pure melting ice at standard atmospheric pressure and is assigned a value of 0 degree Celsius. So this is basically the apparatus which he used in order to find out this ice point or the lower fixed point of water at the point where the water starts to melt. So he take a conical flask here and which was open from the lower side of the vessel, and he kept a beaker below it, and then he fixed this apparatus, this flask, with a stand, and then he pour or put the ice cubes inside it in order to find out the ice point or the point at which these ice cubes will turn into water drops. And in order to find out the temperature or to measure the temperature of the spot that on which these ice cubes will be converted into the water droplets, he places a thermometer inside it vertically. So after some time, he noticed that the ice cubes starts to convert into water droplets. And when he observes on the thermometer, the reading was at 0 degrees Celsius. By this, he came up with the conclusion that 0 degrees Celsius will be considered as the ice point or the lower fixed point of the water. whereas the steam point is the temperature at which boiling water changes into steam at standard atmospheric pressure and is assigned a value of 100 degrees Celsius. So, this was the apparatus, one of the apparatus which can be used to find out the steam point or the upper fixed point of water. The scientists took the round bottom flask. He placed this flask on a tripod stand and placed a burner in order to heat the water, which is inside the round bottom flask. And he fixed this flask with a stand in order to prevent any damage. So here he gives an outlet for the steam when the water will be boiled, and to find out the temperature at which the water will convert into steam, he places a thermometer vertically. So, after heating the vessel, after some time, he observed that the point at which the water starts to convert into steam and starts to leave this flask by the help of this capillary tube, when he noticed the reading on the thermometer, it was indicating 100 degrees Celsius. So by this he came to know that 100 degrees Celsius is basically the steam point or the upper fixed point of the water. This is basically the apparatus which is used to find out the steam point of water. This apparatus is basically known as hypsometer, used to find out the upper fixed point. It is totally encapsulated in order to prevent any other pressure or any other obstacle. It is double walled. From one side it has a steam outlet from which the scientist will be able to know that now the water starts converting into steam. And in order to find out the temperature at which the water is converting into steam, he places a thermometer inside this chamber. And on the other side, he places the manometer, which is basically used to manage the difference in the gas pressures. So we can use both the apparatus, this hypsometer and this apparatus, in order to find the steam point of water. Here you can see that this is the apparatus used to find out the ice point of water or the lower fixed point of water, and these two are the apparatus, the hypsometer and this apparatus using the round bottom flask. Both can be used in order to find out the steam point of water. So now let's move on to our next topic, that is about the measuring temperatures. So, any physical property of a material can be used to measure temperature that varies steadily with the change in temperature. As we have discussed, mercury, alcohol, glycerine, etc. can be used to measure the temperature because of having different melting and the different boiling point, or having different sensors of temperature measurement. So now let's discuss different types of thermometer. Liquid in glass thermometer, which is most of the time made up of the mercury or alcohol. The other is constant volume gas thermometer, bimetallic thermometer, thermocouple thermometer, liquid crystal thermometer, and the resistance thermometer. We'll discuss all these in brief in our upcoming slides. So let's begin. First, we have liquid and glass thermometer, as we have discussed in our previous slides as well. So, the volume of a fixed mass of liquid changes steadily with the temperature. So, with the increase in temperature, the liquid inside these thermometers will increase, and with every degree decrease in the temperature, the liquid inside these capillary tubes or inside these thermometer will also decrease. So this is basically known as the clinical thermometer, or the thermometer having a mercury inside it, and this thermometer is basically known as the laboratory thermometer, or as it is having an alcohol inside it. Then we have another type of thermometer known as constant volume gas thermometer. In this, the pressure or fixed mass of gas at constant volume varies uniformly with the change in temperature. The physical change exploited is the variation of pressure of a fixed volume gas as its temperature changes. The volume of a gas is kept constant, as the name shows, constant volume, by raising or lowering the reservoir B to keep the mercury level at A. Here. The pressure is indicated by the height difference between reservoir B and column A, as you can see here in the diagram as well. So this is basically the apparatus of constant volume gas thermometer. It is a mercury reservoir, and this is the flexible hose by the help of which we can raise the reservoir B in order to keep the mercury level constant in the reservoir A up till this level. And this is basically the bath or the environment to be measured. In this, if we want to find out the temperature of a cold water, then we'll place a cold water in this beaker. Or if we want to find out the high temperature of a water or the boiling water's temperature, so we will place that warm water inside this beaker, and we'll place this bulb inside this beaker, as it contains gases, and when these gases will sense the temperature of this beaker, they will either expand or contract respectively, depending upon the water, for example, or the liquid which is placed inside this beaker. So dear students, let's now have a view of the practical performance of this thermometer.
So now we're going to see the gas thermometer working. So we're going to raise the gas, or raise warm water into the gas, and the gas will expand. Notice we've got the starting levels of the mercury with the two arrows there. Then as the warm water heats the gas will expand, which will force the mercury down on the right hand side and up on the left hand side. But this will also increase the pressure as well as the increase in volume. So when it reaches equilibrium and the two levels of mercury don't change anymore, then what we will do is come along, we'll grab the left hand side of the tube and lift it, further increasing the height of the mercury, increasing the pressure, which will then force the mercury on the right hand side to come back to the level that it started at. That's happening now. And when it gets to the level that it's starting at, we can see on the left-hand side the height difference of the mercury, and from that we can calculate new pressure that the gas is under at the same volume.
Now I hope that you have a better understanding of this topic, that is constant volume gas thermometer. Now let's discuss the other type of thermometer, which is known as bimetallic thermometer. A bimetallic thermometer are made up of bimetallic strips formed by joining two different metals having different thermal expansion coefficients. Basically, bimetallic strip is a mechanical element which can sense temperature and transform it into a mechanical displacement, as we have discussed about this bimetallic strip in our previous topics, that was in the application of thermal expansion and contraction. In different electrical appliances we have discussed about this, that upon heating how these bimetallic strips will change its shape. So basically here you can see the bimetallic thermometer. Here is basically the bimetallic strips are placed in a coil. So by the effect of thermal expansion and contraction, these bimetallic strips will either expand or contract respectively depending upon the temperature. So for example, if the bimetallic strip or the thermometer is used to find out the cold temperature, so due to the cold, when these bimetallic strips will sense the cold of that object, they will contract. And when they are used in order to find out the hotness of something or the warmth of an object, so after absorbing that heat, the bimetallic strip or the coil of bimetallic strip in this thermometer will expand respectively. And this indicator is basically showing the difference or indicating the temperature change of a particular body. So this is basically what the construction of this bimetallic thermometer. A coil type bimetallic strip is used, as you can see here as well, and this is the indicator which is showing the difference in the temperature or indicating different types of temperature. So let's discuss this type of thermometer in a bit detail.
In industrial temperature measurement, there are typically two types of dial thermometers: bimetal and gas-actuated thermometers. Both feature different functional principles and are thus suited for different areas of application. A bimetal thermometer measures the temperature via a spiral tube which consists of two different metals. These metals possess different thermal expansions. The bimetal bends in one direction with heat and in another with cold. Through the mechanical deformation of the bimetal strip in a spiral tube, a rotational movement results caused by temperature changes. This is transferred through a pointer shaft to the pointer of the instrument. The gas-actuated thermometer operates on a completely different principle. The gas, preferably helium gas, expands at elevated temperatures and deforms the measuring tube. So which thermometer is right for your area of application? Due to their simpler construction, bimetal thermometers are significantly more economical. Another advantage: changes in the ambient temperature have no influence on the measuring result. With gas-actuated thermometers, changes in the ambient temperature affect the measuring result. These can be partially compensated. On the other hand, gas-actuated thermometers have important advantages Because of the rapid change in pressure in the closed system of the gas-actuated thermometer, the temperature can be displayed almost instantaneously, whereas the spiral tube in the bimetal thermometer responds much more slowly to temperature changes. Gas-actuated thermometers can be used as much as 60 meters and more away from the measuring point via a capillary. Bimetal thermometers, on the other hand, can only be read directly at their measuring point. Gas-actuated thermometers enable a significantly greater span than bimetal thermometers. Case fillings for gas-actuated thermometers are also possible at median temperatures of over 250 degrees Celsius. Whether a gas-actuated or a bimetal thermometer is used depends on a number of different factors.
So, these are some of the advantages and disadvantages of bimetallic thermometer by comparing it with the gas-actuated or constant volume gas thermometer. Now, moving on to our next type of thermometer, which is known as thermocouple thermometer. It is a device for measuring temperature. It comprises two dissimilar metallic wires joined together to form a junction. Here, as you can see in the picture as well, it is the hot junction and this one is the cold junction. When the junction is heated or cooled, a small voltage is generated in the electric circuit, which can be measured, and this corresponds to temperature. A device which is used to convert heat into electrical power is basically termed as thermocouple thermometer. So as you can see in the diagram as well, this is basically the circuit of this type of thermometer. One measuring junction is hot and the other is cold junction. And these are two dissimilar metal wires. So one side is cold and the other side is hot. Because of this, a current will starts to flow in these dissimilar metal wires, and by the help of this voltmeter, that current or that voltage can be measured. Let's see practically how this circuit basically works and how we can be able to measure the temperatures by using this thermocouple thermometer. As here you can clearly see the difference between these two wires. One is attracted by the magnetic, whereas the other is not. So these are two dissimilar wires. Now he's trying to making a junction between these two dissimilar wires. This is basically the voltmeter by the help of which he would be able to find out the voltage in between the circuit, moving in between the circuit. Now he will heat one of the junction. As you can see in the voltmeter, the reading. Whenever he heats the junction, the voltmeter shows indication of high temperature. And when he places the same junction into the cold water, the reading decreases in the voltmeter. As now you can see here that due to the two junctions, now the electricity or the voltage will be greater. I hope that now you have completely understood the working of this thermocouple thermometer. Now let's move on to the next type of thermometer, which is basically known as liquid crystal thermometer. This is also known as temperature strip or plastic strip thermometer. It's a type of a thermometer that contains heat sensitive or thermochromic liquid crystal in a plastic strip. This strip that change color to indicate different temperatures. So as you can see here in the strip, at different temperatures, the liquid crystal is glowing differently or in different colors. So, liquid crystal thermometer use liquid crystals that change color in response to temperature change. Mixture of liquid crystal are enclosed in separate partitions. So, they are enclosed here at different levels in different portions. Numbers on the partition indicates the temperature according to the amount of heat present. Liquid crystal thermometer includes some indoor digital thermometer as well and a fever thermometer, which are placed on the forehead. So this is very convenient way in order to find out the temperature, for example, the temperature of a human body. Rather than keeping the clinical thermometer for a longer period of time, for example 10 minutes to 15 minutes, in order to find out the temperature of the body, it is much more convenient to have this liquid crystal strip and place on the forehead for a few seconds, and then you can easily find out the temperature of a person's body, as this is basically 37 degrees Celsius or 98 degrees Fahrenheit, which is the normal body temperature. When the temperature of the person's body, for example, is below this normal body temperature, then the crystal will glow with a blue light. Whereas if the temperature of the person's body is greater than 37 degrees Celsius, so this indicates a little bit fever or the high temperature, and by this the crystal will glow with different colors. For example, with brown at 38 degrees Celsius and with a red at 39 or 40 degrees Celsius. So This is how this liquid crystal thermometer works, by showing different colors or different glowing colors at different temperatures. Now let's discuss another type of thermometer, which is known as resistance thermometer. So, resistance thermometer are a type of sensor used to measure temperature. They are usually used to measure temperatures between -200 and 500 degrees Celsius. So these resistance thermometer basically works by changing resistance with a change in temperature in a repeatable manner. As you can see here in this picture as well, here is basically the this plate is basically a resistor, and with the every degree increase or decrease in the temperature, the resistance will be increased or decreased respectively, indicating that there is a change in temperature of a certain object. Let's understand this such type of resistance thermometer in a bit detail.
Every day, various substances are processed, conveyed and stored in pipes and tanks in the process industry. Examples include liquids such as milk, water or oil, and gaseous substances such as natural gas or biogas. Given that these media are processed at very different temperatures and in diverse operations, various measuring principles are used. One of the most frequently used methods is resistance temperature measurement. Temperature plays an important role as a physical quantity. As early as 1742, Swedish physicist Anders Celsius defined the conditions for an international scale of temperature measurement. Approximately 100 years later, William Thomson, subsequently Lord Kelvin, devised the concept of absolute temperature in his work on thermodynamics. The difference between two temperature values of 1 Kelvin unit and 1 degree Celsius is always equal. In honor of these two gentlemen, the legal units for temperature measurement were named after them. Temperature is the most commonly measured variable in process automation. Thermometers generally consist of a thermowell, which houses a rod-shaped tube as the main element. This is the measuring insert, and it has a temperature-sensitive sensor fitted in its tip. Nowadays, resistance sensors based on thin film technology are the most commonly used. Platinum resistors, known as PT100 sensors, are mostly used. A very thin conductive track made from the precious metal platinum is deposited onto a ceramic substrate. When a voltage is applied during operation, current flows through this electrical resistor. This means that electric charges in the form of electrons move through the atomic lattice structures of the platinum. The schematic diagram shows the flow of electrons through the atomic lattice of the platinum conductor. If the temperature of the platinum rises, the natural oscillation of the metal atoms increases. This impedes the current flow more and more, and the electrical resistance increases. A PT100 sensor has a resistance of 100 ohm exactly at 0 degrees Celsius. This value increases if the temperature rises and decreases if the temperature drops. The resistance measurement is passed on to an electronic evaluation unit known as a temperature transmitter. This converts the measured resistance value into a standardized interference-resistant output signal. This signal can be shown on a display. Furthermore, the transmitter checks if the measurement results provided by the sensor are plausible and detects any defects in the electrical wire. Resistance thermometers with platinum sensors offer distinct advantages. The high level of accuracy and long-term stability of the measurements are the most notable. They can also be used over a wide temperature range. Endress and Hauser temperature measuring devices facilitate the measurement of temperatures both in standard applications and in areas of application with specific requirements, such as in hygienic processes, in installations where vibrations occur, or at high temperatures. We have the appropriate solution for any application.
So, I hope students that now you have understood how this resistance thermometer basically works. That whenever the temperature of the body, for example, increases, so with the increase in the temperature, the vibration of the molecules of the the vibration of the molecules of resistors increases and hence causes hurdles for the electric current to flow. And by the help of this, the indicator or the pointer will show indication or a variation that the temperature change has occurred. So, whenever the temperature of certain object increases, the resistance also increases, hence indicating that the temperature of certain body has been increased, and the vice versa. That is, if the object is cool, then the resistance will also be small. The current will easily flow. And by the help of this, we can see that certain object's temperature is low. So students, this was all about our today's lecture. To sum up, today we have discussed a review of the previous topics, then liquid and glass thermometer, the ice and the steam point, and in the end we have discussed certain measuring temperature devices. I hope up till now this chapter is cleared to all of you. Looking forward for your positive response. In our next class, we'll discuss the transmission of heat energy. Till then, take care of yourself and thank you.